Hello guys, welcome to the next lecture of IAL Unit 1 and this is your instructor Mac. Today we'll be discussing graphs of motions and graphs of kinematics. If I first of all go over your specifications, you should be able to draw and interpret the displacement time, velocity time and acceleration time graphs. You should know the physical quantities derived from the slope of the area of the displacement time, velocity time and acceleration time graph, including the case of non-uniform acceleration, and understand how to use the quantities. So I'm going to be very clear to you. The next two lectures regarding the graphs are going to be like just for the sake of understanding all the graphs and what motions can be. And in the third lecture of graphs, that are going to be around 6 to 7 lecture of IAS Unit number 1. Then and there you'll be able to understand what the graphs are meaning, and then we'll be doing a lot of past papers so that you can have a great understanding of these graphs. Stay very focused, stay very relaxed, listen to one by one, go on chapter by chapter so that you can actually do the understanding. These books and efforts I've made just for the sake you guys can get a very good grade. Okay, we have to discuss three graphs in total. Number one is a displacement time graph. Number two is a velocity time graph. And number three is an acceleration time graph. You need to actually understand that the displacement time graph's gradient gives us the values of velocity, and the area of a displacement time graph gives us nothing. There's no quantity that we get from the area of a displacement time graph. Whereas for the velocity time graph, if I get the gradient y2 minus y1 over x2 minus x1, I would get the value of acceleration. So the velocity time graph's gradient gives us acceleration, and the area gives us displacement covered. Last is acceleration time graph. The acceleration time graph's gradient gives us rate of acceleration, and the area gives us change in velocity. Not very much asked in your examinations, but the primarily focus of the examiner is going to be these two graphs. We'll be discussing a lot about these graphs, don't worry, but they are usually asked in MCQs, sometimes in the theory exams as well, but mostly you have to understand how to go from this to that, and there's a lot of things that they're asking, and there are a lot of cases. We'll come to that. Stay very relaxed, starting off with some generic graphs. What does the graph actually means? If this, like I'm like not putting any quantity right now, I'm just going to be explaining what that graph actually means. So starting off from the first one, if this is the straight line, the graph has a straight line. Wherever there's a straight line on the graph, doesn't matter. You have to actually understand that that means that the graph has a gradient value of 0. There is no gradient. M represents gradient. So gradient is 0. That means there's no y2 minus y1 or x2 minus x1 value. You need to realize that. Okay. A straight line graph going up is a uniform gradient graph. Gradient is uniform. That's constant gradient. And the gradient is positive. So there's a positive gradient and it's staying the same. If, for example, there's a straight line and a displacement time graph, and the gradient actually means velocity, that means there's no change in velocity, that's uniform velocity. Just for the sake of understanding, if this graph would have been a velocity time graph and the graph would have straight line, gradient gives us acceleration, that means it's going to be constant acceleration, uniform acceleration. So this is a gradient not changing, like the gradient is not changing for this graph. That's a straight line with uniform positive gradient. All right, this is a uniform negative gradient. M is negative and uniform. Uniform, you can say constant, and this is a negative gradient. This is undefined gradient, undefined. You can say it's infinity, but it's undefined. Any line like going like this, that means it's like instantaneous came to rest or something instantaneous happened. Okay. This is an increasing gradient curve. So in this curve, there's an increasing gradient. Like it's positive and increasing. This is a decreasing gradient curve. You need to actually understand that. And still positive. If you were to make a line over here, you would actually realize that this graph is getting steeper. So the gradient of the graph is getting steeper. The graph is getting steeper the gradient of the graph is increasing, this actually shows that, yeah, the graph is getting steeper. It's a positive gradient curve. Then there's this. This is a decreasing positive gradient. Initially, the graph was more steep, and the graph is like the steepness of the graph is decreasing. You can actually understand that by just looking at the values. So, this graph in general is the increasing gradient graph. If this would have been any quantity that would have been representing gradient in this case, that quantity must have been increasing. If let's suppose the gradient gives us, for example, the gradient gives us velocity, so this is going to be increasing velocity. If the gradient gives us acceleration, it's going to be increasing acceleration. So it's an increasing gradient graph. And this graph is a decreasing gradient graph. Whatever quantity we actually get from the gradient, that quantity is basically decreasing. It's a decreasing gradient graph. All right. This is an increasing gradient negative. Negatively increasing gradient. So you realize that this is a negative gradient line, and then this, since the line is increasing, so the gradient is also increasing but in negative. And this is a decreasing negatively decreasing gradient. So if this would have been a velocity time graph, the deceleration would have been increasing and the deceleration would have been decreasing. So where are these graphs going to be applying? I'm going to be coming to that. But if you have a generic idea what these graphs means, zero gradient, uniform negative, undefined, increasing gradient, decreasing gradient positive, increasing gradient negative, and decreasing gradient negative. These are the 8 graphs that in general we'll be using in different case scenarios. First of all, we'll be coming to displacement time graph, and we are going to be actually understanding what are displacement time graphs. So displacement time graph, the gradient gives us velocity. My child, gradient of the displacement time graphs gives us velocity. If the graph is, first of all, let me just draw the first graph. That's going to be this. If let's suppose I've got a car and that car is standing on its original position. This is the original position of the car. And if the car is standing at that point, let's forget about the car. Let's take you guys. Let's say this is you. If you're standing at the position, at the original, the starting point, and you're not moving, that means you're not covering any displacement. So your graph is going to be like this. It's a rest graph at starting point or original position, whatever suits you. If now this is done, now let's assume that you guys are standing, let's say you're standing 10 meters, you're not moving, you're just standing 10 meters from a starting position. This is still rest, but this graph represents rest in positive displacement. For example, let's say if this is me, you guys are there, this is my original position. If I go over here, then I'm like displaced on the positive side. Na? That's positive displacement. Still I'm at rest. I'm not moving. The displacement gradient of the displacement type graph gives us velocity. Here the gradient is 0, velocity is 0. Here the gradient is 0, velocity is 0. But I'm rest in a positive displacement. I'm like not at my home, not at my starting point. I'm somewhere positively displaced, standing there, not moving, but I'm there. Okay. If the case would have been the other way around, let's assume if you would have been at the negative side, you would have been minus 10 meters left, I mean, let's say 10 meters to the left, the graph would have been like this. It's still a straight line below the gradient. Now, this actually means that it's rest in negative displacement. Negative displacement means in the opposite direction. You are in rest in the opposite direction. So that's rest in the mean position on the like starting point, rest in the positive displacement, rest in the negative displacement. These are all the graphs for the rest first. Okay, moving on. You can pause the video, listen to this again and again, I don't mind. But I'm just gonna be like rubbing out these. If you need the books, you need these books that I've made, you can contact on WhatsApp. It will be delivered to your doorsteps. Okay, moving on. Now, if from my starting point, I'm going to the right with a uniform velocity. So I'm like this, tick, tick. I'm moving to the right, to the right. I'm moving to the right from my starting point. That means I started from my original position and I'm moving with the uniform velocity. So this graph is uniform positive velocity, and I'm going from my original position to the right. To the right. Now this is going to be getting very interesting. I started from my original position, from my starting point, and I covered a positive displacement with a uniform speed or uniform velocity. What if I was starting at a starting point? Let me just use green color for this one. And I move to the left with a uniform speed. So if I were to move to the left, this is the graph. I'm still moving in uniform negative velocity to the left. It does not mean it has to be left all the time, but if let's say one direction is positive, let's say if this is like I move here or if I move here, these are two different directions. So for the positive direction, I'm going to be going above the axis, and for the negative direction, I'm going to be going below the axis. This shows uniform positive velocity to the right, and this shows uniform negative velocity to the left. Uniform negative velocity means I'm going to the left. Okay, makes sense. Moving on. 100% same concept, but in this case scenario, this is going to be very interesting. Stay with me. This is going to be very interesting. Stay with me. If I am already in the right, sorry, I am already in the left, that means I'm in the left. That means I'm starting from a negative displacement. Stay with me. I'm going to just put this text over here so that like makes a little space. Yeah. Right, guys, stay with me. Okay. If I start from a negative displacement and I'm going with a uniform velocity to the right towards my original position, so the graph will look something like this. What are you saying is I started off with a negative displacement. I had, and let's say negative 100, I was there, 100 negative, 100 meters to the left, and I was coming back to my starting point, original position. So the graph is going to be from negative towards the mean position, and the graph would look somewhat like this. And in case I started initially from, let's say, positive 100 and I came back towards my original position, graph is going to be looking something like this. So if let's say I'm already in a positive displacement and I'm coming back to the left towards my mean position, the graph is going to look like this. Kids, even though I was in a negative displacement, but since I was moving to the right now, since I was actually moving to the right in the first case, in the first case, in this case, my velocity is positive because I'm moving to the right. Not like, even if I am like 100 meters in the left, I'm like standing there and I started running towards the positive displacement. Eventually, I would reach zero first, but throughout this time, since my line is like sloping upwards, my gradient will be positive and I'll be having a positive gradient. So this is something that you need to understand, that if I am moving to the right from a negative displacement towards the original position, my velocity will stay positive. And when I'm moving from a positive displacement towards zero, that means I'm moving to the left, therefore my velocity is negative. So this is very important, that even though my displacement was positive throughout, because I was like coming from here to here, I'm going to be positively reducing, eventually reaching zero, but my velocity is going to stay negative. Okay. So these are the graphs for uniform speed from the mean position to the right or the left, or from the right or the left towards the mean position. These are the two graphs that they're like basically four that you need to remember, because I'm going to be using all these graphs for a combined concepts later on. Okay. Then I've got two more, basically a lot of more, but okay. So now I'm going to be making acceleration graphs. Yeah, okay. This is a very, all right. My kids, if you actually understand this, you would realize that the gradient of the graph is increasing. You getting my point? Gradient of the graph is in this case increasing. The graph is getting steeper. That means if I were to write over here and understand that gradient in this case, gradient is increasing and positively increasing. Since the gradient of displacement time graphs gives us velocity, so since the gradient is increasing, that means velocity is increasing. And if I were to make a concept over here, you need to actually understand this is very important, kids. Very important. Okay. So I'm basically, my sticky man just fell off. Okay. I'm basically accelerating to the right from the starting point, because I started from zero. That means initially my displacement was zero. And then I'm like speeding up towards the right. This is acceleration in the positive direction. Acceleration, velocity is increasing. That means it's acceleration in the positive direction. Acceleration in positive direction. Now, if this graph would have been somewhere like this, if this graph would have looked somewhere like this, something like this, the other way around, you would actually realize, I hope you realize, that this graph, the second one that I drew, the velocity, the displacement is being covered. The gradient is still increasing. See, like the graph is getting steeper, steeper. It's negatively increasing graph that I just drew in like generic graphs. This graph shows that the object is accelerating, still accelerating. But this time the object is accelerating in the opposite direction, in the negative direction. The velocity is increasing, but it's increasing in the negative direction. I hope you understand the concept, because the gradient for this one and this one both are increasing. This is positively increasing. Displacement time graph's gradient gives us velocity. So the velocity is increasing in the positive direction, acceleration in the positive direction. In this case, gradient is increasing. Gradient increasing. And gradient is increasing in the negative. Velocity is increasing. You can't say that velocity is not increasing. Velocity is increasing. Increasing negative velocity means the object is moving. That's acceleration in negative direction. I hope this makes sense. Well, this is something that should make sense. This is very, very interesting. Okay. Now, same concept, but since it's a displacement time graph, kids, IAS is not easy. For a very good grade, you have to put a lot of efforts. You have to watch this lecture like 4 or 5 times so that you can make your concept straight, make these graphs in your notebook. If you need the books, you can get the books. I'll get them delivered. But if you do not need the books, you like make it on the piece of paper. You can do that. That's not an issue. Okay. Kids, now I'm going to be starting off with a positive displacement. In this case, I'm going from a positive displacement, accelerating towards the mean position. So I'm going to be like going from positive, accelerating towards the mean position. That means if let's say I start from rest and I'm at this, like let's say positive 100, and then I'm accelerating, that means my velocity is going to increase. And since I'm going to the left, that means my velocity is going to be negative. So my graph is going to look somewhat like this. Guys, this is going to be very interesting. Like this concept, like if you understand what I'm doing right now, that means you are man good in physics. If you're actually getting my point and you're like actually getting it, that means there's nothing that is going to stop you to get an A. Okay, so if you would realize that the gradient is increasing, graph is getting steeper, starting from rest, and I'm already at a positive displacement, and I'm going towards the mean position, and I'm like accelerating. So starting from zero, accelerating towards the mean position, this is the graph that you would draw. And similarly, if you're at the left hand side, and let's say you are to move to the right from a negative displacement towards the mean position, accelerating, so the graph would somewhat look like this, somewhat exactly look like this. Like this is going to be the shape of the graph more or less. So this is going to be like, if you would realize, this is actually the understanding. So in this case scenario, you can actually observe that yeah, just make it a little proper. Okay, so this initially it starts from rest, the gradient is 0, and then you can clearly observe that the gradient is increasing somewhat. So the graph is going to be like getting steeper in positively increasing gradient. That means it's like moving to the right, starting from rest and accelerating. So this is basically acceleration from negative displacement, from positive displacement. Positive displacement means like positive, like this, like positive the direction you're initially there, and towards mean position. And then this is acceleration from negative displacement towards mean position. So these are all the graphs of acceleration. Displacement time graph, there are like only acceleration. There's no increasing, decreasing, because there's just the gradient gives us velocity. Last is the deceleration curves. Let's say I had like this. If I were to draw this, they're like these are not very important, but they're like important. Okay, so something in the displacement time graph, usually they do not ask about the, like deceleration, but please don't skip this. Understand the concept. It's very important. You have been with me for like last 25-30 minutes, so yeah, a little more and that's it. So if you were realizing that the gradient is decreasing, eventually becoming 0, so this is deceleration. So this is deceleration in positive displacement. So if I like was moving and then I like moving stopped and eventually stopped from the left to the right. So if let's say I was moving and this, like look at the motion of the pen, exactly this. So this is the starting point and like shoom. So I like the velocity was increasing and eventually I came to rest. So velocity was like decreasing and eventually it came to rest. So the displacement times graph's gradient gives us velocity. Velocity is decreasing and eventually straight line, that means it's at rest. And if this would have been the case like this, if we were to be moving to the left and then came to rest, the graph would have been the other way around, is the deceleration in the negative displacement. Kids, this is not a velocity time graph. This is not going to be the deceleration. Make sure that you understand this. It's a displacement time graph. You are not required to confuse it. You are in AS. Please, man, don't confuse. The concepts should be very straight. What the gradient means, what is actually is that meaning. The concepts should be so straight that they should actually make sense. If the concepts are not clear, you need some more guidance. Do text me, ask for basic lectures, understanding of last year's. Make sure that you get a good grade. But without the understanding, it's going to be very difficult. Okay. Last but not the least, I'm going to be doing a displacement. Yeah. So yeah, this is the graph that is like asked the least. MCQs might be possible that this is asked, but in theory, I haven't seen it a lot in your past papers. But my child, they're all part of the syllabus. There's like nothing is like I'm teaching you nothing that is not part of the syllabus. Everything that I'm teaching is part of the syllabus. Okay. So this is like these are all again decelerations, but yeah. So these are two graphs. If you would realize that eventually the graph becoming straight, so I'm coming to rest, and I'm coming to rest at my original house, my starting point. So if this is my starting point, and if something is moving like this, moving forward to the right, and then eventually coming to rest like this, you're parking a car in your house. So your velocity is going to decrease and eventually comes to rest. So you're coming from a positive displacement, eventually decelerating to rest at the starting point. So that's deceleration from positive displacement to mean position. Okay, and then this is deceleration from negative displacement towards mean position. Okay, kids must write the lecture down, understand the things. This is some high class content, and yep, I'll help you a lot. In the next lecture, we'll be discussing what velocity time graphs are. They're the same amount of this one, and they're more interesting. So make sure that you watch this video at least 3 times if you have like a blur understanding. If you're very good at physics, then 1 or 2 times is good enough. Once you're done with that, make sure you actually write this down so that we can start off with the velocity time graphs. See you in the next lecture. Take care. Since you're enjoying the lectures, just wanted to inform you that there are premium batches going on. That is direct way to get A's and A stars. It has got some exclusive content that is not generally available neither on the website nor on the YouTube. So you can join the batch to get your grade.